Alright everybody, so here's the video solution guide to today's worksheet. And then make sure you choose the right one. It's the 30, 60, 90 triangles. And in the first part, we're just simplifying radicals. Now remember, when you're multiplying two square roots, you can put them both underneath the same square root. I don't know what was going on with the light. And then you can multiply them. And then we all know the square root of 9 is 3. Okay, so that's how that guy simplifies. Number 2, 2 times the square root of 3. You cannot bring that 2 underneath the square root. And actually, there's nothing we can do with that guy. It just stays the same. 2 times the square root of 3. Okay. Sounds like my wife's having a party over there. And then number 3, whenever you have square roots in the denominator, we want to get rid of those. And the way we do that is we multiply the numerator and the denominator by the square root of 3. My lighting is horrible in this room. So when we multiply the top and the bottom by the square root of 3, this is what we end up with. Okay, again, the top kind of looks like this, where you have a number times the square root. So here we have 4 times the square root number. So that stays the same. And then the bottom, we actually just simplified the bottom here. Square root of 3 times the square root of 3, we got was 3. So here at the bottom, we have square root of 3 times the square root of 3. I know that's just 3. Sometimes I'll do the shortcuts. And other times I'll show all the work. Like for this next one over here, I'm going to show you a little bit more work. So again, we want to get rid of any square root in the denominator. And actually, we're going to multiply the top and the bottom by the square root of 3. Now, why the square root of 3? Because that's the one that's in the denominator. And that's what I want to eliminate. Okay, remember, when you're multiplying two square root numbers, you can actually bring them both underneath one square root. Now, I could have just put 3 down here, but since I'm going to show you a little bit of work for the top, I figured I'll just show you some work for the bottom also. So that's the square root of 15 on top, that's the square root of 9 on the bottom. We cannot do anything with the numerator, so that stays the square root of 15. But the bottom, the denominator, we know the square root of 3 is 9, right? We already knew that from the beginning, but that's how we get it. Okay, so let me go over here to number 5. So again, if you look at 5, we have a square root number in the denominator. We want to eliminate that. So then on the top, I'm going to kind of do what I did for number 4 to this one. I mean number 3 to this one. 3 times square root of 3. That says 3 times square root of 3. And then the square root of 3 times the square root of 3, we've already done it once, twice, 3 times. I know the answer is just 3. Now you would think, hey, I'm done, but you should recognize that there's a 3 in the numerator and 3 in the denominator. Those actually divide out, and your answer is just square root of 3. Okay. Let's go to 6. Same thing, multiply the numerator and the denominator by the square root of 3. Oh, you know what? Actually, I'm glad I did that, because sometimes if you watch this, 12 is divisible by 3. So watch what happens. I'm going to actually stop this for a second. And okay, now I could have continued with multiplying the top and the bottom by the square root of 3. But sometimes students will be like, hey, I know 12 is divisible by 3. And you can go ahead and divide them. Right? Right? They're both underneath square roots. Just put them both underneath the square root and then divide it. Now what happens when you divide it is you get 12 divided by 3 is 4. And then you're left with this simple square root to solve, which is just 2. Now I would have gotten 2 if I would have worked it out the other way. But I think it would have been more work. You guys should recognize that 12 divided by 3 is 4, and then you can take the square root of that. So grab those, pause this and grab those, and then we're going to move on to the 30, 60, 90. So just like the 45, 45, 90 triangles where there was a special relationship between the sides, or like those two equations that we used, the 30, 60, 90 has also a special relationship between the sides. Whenever you see a 30, 60, 90 triangle, you should think these two things automatically. The hypotenuse is 2 times the short leg, and the longer leg is the short leg times the square root of 3. Now, you don't have to have these memorized, but you do have to have them written down, and you do need to know how to work with them. So what I do, and what I'm going to do in a second from now, I'm going to show you to solve all of these. I'm going to write, this seems excessive, but this is how we solve them. I'm going to write these two equations on every single one of these problems. Okay, so I'm going to pause this for a second. So now if you look at my number 7, I have the equation written down twice. And if you look at my number 8, I have the 2 equations written down actually. Okay, so watch. So then you need to go back. You need to go back to the diagram. And you're like, okay, this is 60, that's 90, so this top one up here should be 30. We need to figure out which one is the hypotenuse, which one is the short leg, and which one is the long leg. And then put that stuff into the equation, and then figure out the values of x and y. Now, I always like to find the hypotenuse first, because we know the hypotenuse is always across the square angle, or the 90-degree angle. So I know this over here is the hypotenuse, which is x. So if you want to go ahead, put an x instead of the hypotenuse, and then we can find the short leg to finish this equation. Now to figure out which side is the short leg, because again, these two legs, or these two sides are the legs, but one of them is shorter than the other. Okay, to figure out which one the short leg is, just look at the side that's across the 30-degree angle. So here's the 30-degree angle. If you go across from it, this one is the short leg. So I'm just going to put an S here for short leg, and then that's the short leg. So that value I put in here. And then I go over to my other equation, and I actually put it in over here also. The short leg is 4 square root of 3 over 3. Bring down the square root of 3. And then the long leg must be y. So I'm just going to put L here. Long leg. So the long leg is y. So really we're left with these two equations to solve. They look ugly, but they're actually not that bad to solve. It's not quite a lot of work. So if you look at this, you need to think, hey, all of this is in the numerator, so I'm going to multiply these. And actually you can only multiply the 2 and the 4. The square root of 3 does not get multiplied because it's a square root, but it's a square root, and this one is not a square root. And then you still have that 3 in the bottom. So that's the value of x. X equals 8 times the square root of 3 over 3. And then for the y, again, you're going to multiply these two, square root of 3 times the square root of 3. And actually, we know what that is. It's up here for number 1. Square root of 3 times the square root of 3 is 3. So watch, instead of, so I'm going to have to simplify this a couple of times. I have the 4/3. The 4/3 just comes straight down. But that square root of 3 times that square root of 3 is 3. So then you have a 3 in the numerator, a 3 in the denominator. You could multiply and then divide, but I would just like to say, hey, there's one on top, one at the bottom. So there's your answer, y equals 4. And that's the answer for number 7.